Chapter 10 is game theory. So grab a cup of coffee and we're going to go into this material. And this is ways to think that you may not be accustomed to doing very often. But it's fun, so hope you enjoy it. The learning objectives are first to look at the basics of game theory, definition, components, simultaneous versus sequential, one-shot versus repeated. Then we'll look more specifically at simultaneous moved, one-shot games, looking at what are the dominant strategies, secure strategies, Nash equilibrium types of approaches. Applications that we'll look at in the sections would be pricing, advertising, coordinating decisions, and monitoring employees. Then we'll look at repeated games, where we compare a repeated versus a one-shot game. And there are incentives for collusion in this regard. So we'll look at a collusion and the thinking behind whether to collude or to renege. And there is a calculation that we can do to help people decide if they should cheat or renege. Then we'll look at some finitely repeated games. In other words, there is an endpoint. In some cases we know, some cases we don't know. The applications here will be in resignation or quitting by employees. And the second is in the area of what we call a snake oil salesman. And finally, we'll look at multi-stage games where there is a sequence of moves, one party then next. So there's a chance to observe and then choose your action based on what the opponent has already done. First, let's start with an overview. Game theory is a general framework to decision-making when agents' payoffs depend on actions taken by other players. So this is that interdependency that we discussed when we looked at oligopolies in general. Games consist of the following components. First, who are the players? Second, what are the actions? Those are called strategies that may be undertaken. Then there are payoffs for each of the endpoints for the two respective players. Then look at the description of the order of play. Is it simultaneous or is it sequential? And then look at the description of the frequency of play. Is it one shot, repeated, finite, or not finite? So we'll look at all these variations during our material today. One of the distinctions is it a simultaneous move game where there's no knowledge and we make a decision blind and we see what happens. Sometimes it's called the Bertrand duopoly game. Secondly, there's a sequential move game where there's one move, the other side sees the move and then chooses based on that knowledge. We'll look more at the simultaneous and then we'll look at an example of sequential move games. Frequency, is it one shot or is it repeated? And these are major determination in your strategy to employ on which choice you make. In the simultaneous move, one-shot games, the theory is we set a strategy so that we are at a decision point and then we can execute on that strategy. Normal form is where there's the number of players, they have strategies, and the payoffs from those strategies. So we're going to stay with normal form games where these are known characteristics of the game. Normal form game looks like this. We have two players, A and B. We have strategies that can be employed by the respective players. In this case, A may choose to go up or down, and B may choose to go left or right. Then there are payoffs. Within each box, there are two numbers. The first number corresponds to what A would get if that was the outcome, and the second is what B would get if this is the outcome. Possible strategies are first, what are the dominant strategies if one exists? They don't always exist, but if they do, you like it because in this case, the highest payoff to the player results from the choice, and there's nothing the opponent can do to make it not the best choice. So we like things with that kind of certainty and control. Next is secure strategy. This is where you're guaranteed the highest payoff given the worst possible scenario. So we're looking, in a sense, to minimize the downside, and so we're not hurt by the choice that we make. Then we look at Nash equilibrium strategy. This is where we have a set of strategies where neither player can improve their payoff once you're in that box, let's say, given a change in strategy. So they're looking at it, and let's say they could change and move out. They would not choose to do so because any move they make is not as good as the one they're in. So let's show an example of the dominant strategy. Here, the player A has these choices, up or down, and B has left or right. The dominant strategy is the one where you choose it, and regardless of the other player's move, you're going to still be in your best position. So let's start with player A. What A would notice looking at the outcomes here, the payoffs, is that regardless of what happens by B, if A chooses up, they're going to have the better choice. So let's look at player B choosing left. If player B chooses left, the best outcome for A is up. All right. How about if B chooses right? The best outcome for A is also up. Well, that makes it easy. A should choose up because regardless of the action from B, that is still the ultimately a better choice for A. So A has a dominant strategy, up, and any move by B won't hurt them. And notice that B does not have such a luxury because in no case can they see that they're independent, essentially, of the choice of A. For example, if B chose left, then A could choose up, in which case B would be grateful because you'd get 20. If A chose down, it would be 7, in which case B would say, damn, I wish I would have chosen right, because if I had chosen right and A picked down, I would have made more than 7. So in this case, there's no dominant strategy for B, whereas A has it easy. Regardless of what B does, the best outcomes for A are going to be in the same direction, up. Then there's the idea of a secure strategy. This guarantees the highest payoff given the worst possible scenarios. Here, player A has a secure strategy, up. So it guarantees at least a 10% payoff and avoids a negative 10 payoff. So this is a safe strategy for A. So how about B? Well, B also has a secure strategy where by choosing right, they guarantee at least an 8 payoff and they avoid the lowest payoff of 7. So if B chooses right, they guard against a bad outcome.